Find the derivative of y equals to 2x squared times 1 minus 3x plus x squared. Then evaluate y prime of 2. Right now, y is the product of two functions of x. Product means they are multiplying each other. While we do have a product rule, and that can be used, if you can take the product first and then take the derivative from that, it is oftentimes quicker and easier. We can physically take the product here by distributing the 2x squared into the expression, and that will give us 2x squared, and then 2x squared times a negative 3x will give us a negative 6x cubed. There's actually 3 x's altogether there. And then 2x squared times x squared will be a positive 2x to the 4th. You're always adding the exponents when you multiply x's with other x's. So there's our y. From there we can find the derivative, y prime, which can also be called dy dx. The first term is a power rule. Bring the 2 down, multiply with the other 2, and that will give us a 4, and then subtract 1 from the power to give us a power of 1. X to the 1 can be written as just an x. The next term is a power rule. We'll bring the 3 down and multiply times the negative 6 to give us a negative 18, and we'll subtract 1 from the power, which will give us x to the 2. And the last term is also a power rule. Bring down the 4, multiply with the 2, that'll give us an 8, x raised 2, and then we subtract 1 from that power, and it'll be x to the 3. So there's our derivative. The next thing we need to do is evaluate y prime of 2. Y prime of 2 is going to give us 4 times 2 minus 18 times 2 squared plus 8 times 2 cubed. 4 times 2 is 8, minus 18 times 2 squared is a 4, plus 8 times 2 cubed is an 8. So we're going to get y prime of 2 equals 8 minus 18 times 4 will be a 72, and 8 times 8 will be a 64. Sometimes it's easier to pair off the additions before the subtractions. 8 plus 64 is a 72, and minus a 72. So apparently we get y prime of 2 equals to 0.